Hello everyone, my name is Lindy Lobalanay from Group 1. Our topic today is all about science organic sedimentary rocks. Organic sedimentary rocks form from accumulation and lithification of organic debris such as leaves, roots, shells, and other plant, animal material. The hard parts of animals such as bones and shells can become cemented together and over time make it rot. Our plant remains may be covered underground for millions of years. To make an organic sedimentary rock, coal is an example of an organic sedimentary rock. The way in which coal is created is typically of how organic sedimentary rocks forms. Millions of millions of years ago, plants, animals die and become buried. Over time, additional layers of peat, late night, and sediment get added to the original organic matter eventually, and this sedimentary and organic matter accumulates and will be transferred by pressure and heat into coal. Some limestone is another example of organic sedimentary rock. Organisms such as oyster, clams, mussels, and coral die and their shells and bones are broken down by the ocean and settle onto ocean floor. Over time, these layers of sediment begin to form, and during burial and lithification, the sediment precipitates out of the water and limestone is formed. Phosphoriferous limestone is limestone with a large number of fossils. This is because the once living organisms died and are cut over by sediment, which over time create pressure and lithification and transform the fossil and sediment into rock. I hope you like it. Thank you.
Good morning and good afternoon, everyone. This is my report. Lithification. Sedimentary rocks are created when little pieces of sediment, such as pebbles, sand, and clay, join together. Okay, that seems simple enough, but how do these little pieces of sediment stick to each other to form a solid rock? If you think about it, you could go down to the beach and pick up a handful of sand and try to squeeze the sand grains together really hard, but once you open your hand, the sand will run through your fingers. You could try whipping the sand with water. This would hold the sand together for a short time, but once that water evaporated, the sand grains would once again separate. So there must be some trick to get sediment to combine and form solid rock. In this lesson, we will learn about something called lithification, which is the process by which sediments combine to form sedimentary rocks.
Hello everyone, my name is Jenny Ligarde from Group 2. Our topic today is deposition of sedimentary rocks. Sedimentary rocks are formed when sediment is deposited out of air, ice, wind, gravity, or water flows carrying the particles in suspension. This sediment is often formed when weathering and erosion break down a rock into loose material in a source area. What is an example of rock deposition? Deposition happens whenever there is wind or moving water. Rivers deposit sediments in a fan-shaped delta where they empty into the ocean. In caves, water carries limestone from rocks above and drip it down in small amounts, creating stalactites and stalagmites. Summary of deposition of sedimentary rocks. The deposition environment plays a crucial role in determining the characteristics of the resulting sedimentary rock. Factors like sediment, source transport, mechanism, climate, and tectonic activity influence the deposition process. The deposition process of sedimentary rock is essential for understanding Earth's history and evolution. These rocks often contain fossils, providing insights into past life forms in environments. They also hold clues about past climates, tectonic events, and geological processes.
The process of weathering. Pre-existing rocks are broken down into smaller particles by physical and chemical weathering processes, like temperature changes, water, wind, and chemical reactions. British Geological Survey said that weathering is a wearing down or breaking of rocks while they are in place. Weathering can be biological, chemical, or physical. Biological weathering occurs due to the movement of plants and animals, such as rabbits, plants, which can cause cracks in rocks to widen. Chemical weathering occurs when rainwater reacts with rock minerals, such as carbon dioxide, causing a reaction. Physical weathering occurs when physical processes like temperature changes or exposure to wind, rain, and waves affects rocks, such as water ice expanding and causing cracks to widen. Both biological and physical weathering contribute to the formation of rock. Mechanical weathering, such as freeze-thaw, occurs in limestone landscape like the Pennines of Yorkshire, where water expands and breaks the limestone apart. Once a rock has been broken down, a process called erosion transport the bits of rock and minerals away. Water acids, salt, plants, animals, and changes in temperature are all agents of weathering and erosion.
The transformation of sediments involves several processes that change their composition, structure, and appearance over time. Key processes include litification. This process turns loose sediments into solid rock through compaction, pressure from overlying materials, and cementation minerals precipitating from groundwater to bind the sediments. Compaction. As sediments accumulate, the weight of the overlying layers compresses the deeper sediments, reducing pore space and squeezing out water. Cementation. Dissolved minerals in groundwater crystallize and fill the space between sediments, grains binding them together into solid rock. Diagenesis. This encompasses all the physical, chemical, and biological changes that occur in sediments after deposition, but before metamorphism. It includes processes like recrystallization, where minerals change form and the formation of new minerals. Metamorphism, when sediments are buried deeper and subjected to high pressure and temperature, they can transform into metamorphic rocks. For example, Shale can become schist or slate. These processes transform sediments from loose and consolidated materials into solid rock formation over geological time scales.
Our topic for today is all about chemical sedimentary rocks. So what is chemical sedimentary rocks? Chemical sedimentary rocks are formed by precipitation of minerals from water or by alteration of already existing material in place. The most common of these rocks includes evaporates, chert, and some varieties of carbon rocks like limestone and limestone. In contrast with plastic sedimentary rocks, petrology is named chemical sedimentary rocks based on chemical composition. This is because chemical sedimentary rocks usually include only one or few minerals. The chemical processes that form them tend to isolate certain elements. The most common precipitated minerals consist of elements of high solubility, for example, alkalis such as sodium or potassium, or elements of great abundance, for example, silicon. Formation, evaporation. When water index, seas, or ocean evaporates, it leaves behind dissolved mineral as the concentration of these minerals increases. They begin to precipitate out of the solution and settle as solid deposits. Precipitation. Some minerals can precipitate out of water even without evaporation. This can occur when water becomes supersaturated with minerals due to change in temperature, pressure, or chemical composition. Types of chemical sedimentary rocks. Evaporates. These form from the evaporation of water in arid environments. Common examples include halite or rock salt, formed from the evaporation of seawater or saline lakes. Gypsum, formed similarly to halite but often in more arid conditions with a high evaporation rate. Limestone, this can form from the precipitation of calcium carbonate from marine or freshwater environments.
Plastic sedimentary rock are formed from the accumulation and multiplication of fragments of pre-existing rock and mineral. These rocks are classified based on the size, composition, and texture of the class. The key classification include conglomerate and breccia. Conglomerate composed of rounded clots larger than 2 mm, typically indicating transportation by water or ice, which smooth the particles. Breccia contain angular clots of the same size, suggesting limited transport and deposition in close to the source. Sandstone, made of the sun-sized particles, 0.0625 to 2 mm, primarily composed of quartz but may include feldspar and rock fragments. Types include quartz sandstone, predominantly quartz. Archrose contains significant feldspar, indicating less weathering. Gray rock contains a mix of rocks, fragments, and matrix materials. Siltstone, composed of cell-sized particles 0.0039 to 0.0625 mm. Those rocks have a gritty texture and often found in environments like river deltas and floodplains. Shales in mudstone, made of very fine particles less than 0.0039 mm. Primarily clay and salt. Shales splitting into thin layer due to the alignment of clay minerals. Mudstone similar to shales but lack of facility and blocky in nature.
Sediment transport is the movement of solid particle sediment, typically due to a combination of gravity acting on the sediment and the movement of the fluid in which the sediment is entrained. Sediment transport occurs in a natural system where the particles are clastic rocks, sand, gravel, boulders, mud, or clay. The fluid is air, water, or ice, and the force of gravity acts to move the particles along the sloping surface on which they are resting. Sediment transport due to fluid motion occurs in rivers, ocean, lakes, seas, and the other body of water due to currents and tides. Transport is also caused by glaciers as they flow on the terrestrial surface under the influence wind. Sediment transport due only to gravity can occur on sloping surface in general, including hill slopes, scarps, cliffs, and continental shelf, continental slope boundary.
Metamorphism. Metamorphism is the process to change existing rock called protoliths into a new rocks with a new mineral and new texture. What is metamorphism? The process by which rock are changed compository, texture, or structure by extreme heat and pressure. Metamorphism is the transformation of existing rock to rock with a different mineral composition or texture. Metamorphism takes place at temperature in excess of 150 degrees Celsius and also at evaluated pressure or in the process of chemically active fluids. About the rock remains mostly solid during the transformation. A type of metamorphism resulting in chemical reconstitution controlled by temperature increases and influenced to a lesser extent by confining pressure.
Hi, good day everyone. I am Karin Joy Almanti and our topic for today is all about erosional agents. Erosional agents play a crucial role in the formation of sedimentary rock. These agents are the force that wear down and transport existing rock, creating the sediment that eventually form sedimentary rocks. Erosional agent and sedimentary rocks formation. Here's how the main erosional agents contribute in the formation of sedimentary rocks. Water. Water is the most significant erosional agent responsible for shaping much of the Earth's surface and creating vast amounts of sediment. Rivers. Fast-flowing rivers curve out valleys, transport large amount of sedimentary and deposit them in a various locations, forming layers of sand, salt, and clay. Rainwater can cause splash erosion, dislodging soil particles and sheet erosion, carrying away soil in a thin layer. Ocean waves erode coastlines, break down rocks, and transport sand and other sediments, forming beach and coastal deposits. Wind erosion, non-aeolian erosion, is especially active in deserts and dry areas.
Good morning, ma'am. Good morning, classmate. My name is Jimar Olantexe, representing Group 2. There are three types of rock on Earth. Sedimentary rocks form when small pieces of rock called sediment are pressed and glued together and minerals. Igneous rock form when rock is melted into magma and then cools and hardens into new rock. The third type of rock forms when other rock changes their appearance. This type of rock called metamorphic rock. The word metamorphic comes from Greek word meaning change of shape. Metamorphic rocks form when sedimentary, igneous, or other metamorphic rock become buried under layer of rocks. The heat and pressure change the way the rock looks. The heat is not enough to melt the rock into magma. Instead, it created changes in the rock's crystal shape. There are two different ways metamorphic rocks form. Sometimes rock changes because they're very deep in earth crust with lots of heavy rock layer on top. This type of change is called regional metamorphism. The high temperature and pressure change the appearance of the rock, turning the metamorphic rocks. Most of the Earth's lower continental crust is made metamorphic rock. The forms of this way, the second way metamorphic rock form is called contact metamorphism. This happens when magma is forced through other rocks. The magma heats up the rock and increases the pressure, but isn't enough to melt them completely. Contact metaformism often happens when tectonic plates come together and push against each other. Geology studies the chemicals and metamorphic rock to uncover the original rock type. For example, limestone is a sedimentary rock that changes into a metamorphic rock called marble. Geologists know this because limestone and marble are both made of calcium carbonate. Granite. Granite is an igneous rock that changes in a metamorphic rock called gneiss. A granite has a spotted a crystal pattern when